So it's about controlling your dependencies. First, I'll just talk a little bit about what who the presentation is for, what it is about, who I am, and it will be three main topics: is why controlling your dependencies or dependency issues can be a problem, specific causes and solutions, where I'll go through an example I've made, and then at the end, the last part is more about how to fix it in current code. There will always be dependencies for one part of the code to another. This is not the problem. You make libraries with functions you use everywhere to make your job easier. Libraries with specific functions like drivers or other functionality, which is a good thing. The problem starts when you lose control over your dependencies and every library is dependent on each other in a mesh where everything is so interconnected that if you change one thing, it affects everything. So when I talk about libraries, I mean more than just libraries. I talk about like actor, classes, interfaces. I all define as libraries for this presentation because they behave in many ways like a library. There's a collection of files and type definitions, with actors and classes and interfaces having some more functionality, but the issues are still the same. Who is it not for? If you don't use libraries, you just use a loose selections of VIs and type defs with no owner, this is not really for you, and if you don't use a project either. The dependency issue might seem like a downside of using libraries or collections of things, but they only exist because of all the advantages they give. If I make a code which isn't just me trying something random, I always use libraries and projects. I rarely use any loose VI, and if I do, it's usually like one main VI or a launch VI, where I launch the root actor, because I use a lot of actor framework, but it can also be a main in a way. That's probably people talk about. And you really should use collections and libraries if you don't already, because it makes your code a lot more flexible and maintainable. So I will talk about the problems you should be aware of while your code grows and increases in complexity. Complexity factors are multiple people working on the same code. The code is reused in multiple projects, or the project contains more than one context like FPGA, RT, or PC, or it's compiled code, like even if it's for our FPGA, RT, and PC. In this, you will get a lot of issues if you don't control your dependency. Even though your project is small and does a simple thing, if there's any ambition on using code as part of something larger, it's very important that you pay attention to your dependencies. Using a small code alone and using it in a bigger project is very different. Some call it integration hell, but the point is the complexity of the whole is much larger than the sum of its parts. So it's good to keep the parts simple. I am Jørgen Steen. I'm a senior developer at Virinco Technology. Virinco mostly make manufacturing tests and is known for developing and maintaining WATS. WATS is a test management software solution used to track your test data. I do not work with test, but instead I work on a larger scale application for monitoring and control. I worked with LabVIEW for close to 10 years, and I worked on large complex application for 8 of those. First at CERN, now at Virinco. My projects consist of, when I say a large project, I mean that it works on FPGA, RT, and PC, and multiple RTs communicating with one PC, actor framework classes all working interchangeably, and where everything needs to communicate, and they share a lot of code to make it maintainable and interoperable, well, that's a hard word, between all the stacks. So like between all FPGA, RT, and PC. Currently, I am the software architect and lead developer of a team of 3 who all work on the same code in parallel. So we're having rules, and proper dependencies are essential. So why do you care about dependencies? Why not just use any library, make use it here, use it there, create circular dependencies. The issue comes when you have unnecessarily long chains of dependencies, like you use like one thing is dependent on the next thing on the next thing. So you use one VI from the top library, and then you drag all the code into this VI, for example. Or you have a circular dependencies, like A is dependent on B, and B is on C, and C is on A. This will cause a lot of issues when you're trying to compile your code and other stuff. So the issues I meet the most is when I compile code for FPGA, RT, or PC, it will take forever or doesn't compile at all. Here, circular dependencies is a real killer. So if you're just playing it fast and loose, you will. They come when you least expect them, and they also come when you don't want them, and they creep up. So they don't. They're often shown hints that they're a problem, but they often just suddenly it's a wall. You don't understand, why can't I compile it? Why do I have to do this and that? And it's because some weird dependencies. There's also often an error in the PC, RT, or FPGA code, because say you have some PC code and it's dependent on some FPGA code, which has FPGA specific code, then you will get an error. So it's important to keep them separated. I use a lot of the same code on the RT, FPGA, and PC, but I have to do it in a clever way, or like at least a planned way, to not get these kind of dependencies. Because there's a lot of unnecessary dependencies that causes change in one part of your library, and then affects all the other libraries because they are dependent on this. And then if you're multiple people working on the same code base, this kind of will affect everyone. So when you try to merge some LabVIEW code, and then the person A has done something that affects the code person B works on, even though the person didn't really change code B, it's just because they're interchanged, like they're codependent, then you will have a hard time merging. And as everyone who uses Git and LabVIEW knows, merging is hard, like actually two different versions of the same VI library or type defs. So it's important to kind of take care of that. Other things are that it takes a long time to open the project. Projects are very easier corruptible if you don't play it loose, and if you don't control your dependencies, and it's a lot more of a headache to maintain. All in all, it makes the project a lot less maintainable and flexible, and it's harder to reuse stuff. So I hope I've kind of clarified why it is a problem to just have a lot of code which just is codependent, and is the reason for having bad dependencies, like uncontrolled dependencies. So next step, I will talk a little bit about the scenario of how to plan your dependencies, how to what to do in certain scenarios. So I created a fictitious scenario with some code. It's not actually anything running. It's just I did this because I wanted to make something simple which I could easily explain. I tried to do this and formulate what I wanted to say in this kind of part where I show the solutions in a way without an example, but I noticed it got a little bit confusing. So I therefore created a scenario where dependencies come into play. This is a small application where one could technically take shortcuts, and the scenarios then the scenario is made up, but it's based on real code. It's like with a real code in my mind. The reason it is small and made up is just to make it easier to convey what I want to convey. On the screen, you'll see all the components of the application. We have two applications running, one on the PC and one on the remote device. This is in this example, the device is a real-time device, or RT for short. On the PC, we have a GUI running, which the operator interacts with. On the RT, we have the controls and measure. On the RT, the software controls and measures the hardware. They communicate with each other over the Ethernet, which specific protocol is not important, but what is important for this example, I'm trying to create the scenario to kind of explain parts of the code, just so it will be easier to understand. And yeah, what's important to understand with the communication library is that it's the same library on the PC and the RT to reduce maintenance, and one has made its own wrapper around it to facilitate your specific way of communicating. Yeah. So also in this scenario, the GUI, hardware, and communication all have a while loop in them, so they are running continuously. The VIs on the side, that's called root, they are just for facilitating some common stuff, but I'll get into that. The data flows between the GUI and the hardware with the help of the communication. And from the GUI, you want to see the values of multiple temperatures and be able to control the temperature of the heater. The hardware can read the temperature and keep the temperature at the target temperature, and the code is set up that they have a common init where everything that is shared is set and initialized, like queues and other common features, and the common close where everything is closed. I call this part root because I use the active framework, and that's what you kind of call it often there. But just to know it facilitates and starts everything. That's the common functionality. There are two roots in the project, one for RT and one for PC. There are two different libraries. They do not share anything directly, but they're called root because they share the same function in a way. They start the application. By design, root, or whatever you would call it, main, or is dependent on everything in their application, but nothing should ever be dependent on them. This is because they are the top level VIs, or the main VIs, as some would call it. They are what package everything together, and if something was dependent on them, it would automatically depend on everything else, creating a circular dependencies. They have things they share and things they do not share. The GUI and RTs have a few queues for themselves, but in this example, they only serve the purpose of showing common things. Like there's something in common for the PC application. The temperature sensor, and now the temperature sensor type def, and the control heat controller is used by the GUI and the hardware. So we have to figure out a way that they don't become codependent. There's also a communication type def, which is a generic format that the communication can handle any data. And there is also a communication queue that is uses in data in and out of the communication loop. These are application-specific queues. And the communication type def and queues are used by everyone. So we have to figure out something with that too. Now that we have established who uses the type defs, we can begin to unfold the consequences of the dependency entanglement. The goal here is that we should not have circular dependencies or have any connections with the GUI. We're trying to make a system which is doesn't have bad dependencies. We could have everything owned by one thing like the hardware, but then everything would be dependent on the hardware. Or we could have some things owned by the communication and some things by the hardware and some things by the GUI, but in the end we will get a circular dependency which we want to avoid. If you haven't gotten this problem before, maybe you just worked on small applications, but this has really been the depth of some of my applications. Let's continue. So with the issues, let's discuss who should own the communication queues. You could think that the answer is very simple. It should be owned by the communication library. And we have set some rules up, or I have set some rules up, which I think is easy to follow. It's that dependencies should only be in one direction, not circular or back and forth. And then if we say they are owned by the communication library, this follows it, because everything can be dependent on the communication, and then the communication is not dependent on everything else. However, if, say, you use a downloadable library for the communication protocol, then now the real-time software and the PC will also be dependent on them. And this can be a problem. Maybe you don't want that. Maybe you want the GUI and hardware to be communication agnostic. The solution around this would be to make another library, which you would call just a communication interface, which could own the queues and the data type which are used by the hardware and GUI. This and would be dependent and used by the communication, of course, because now everyone would be dependent on this library, but it would not be dependent on anything else. The advantage here is that you can reuse, then you could have reuse the communication library anywhere else, and you can easily swap the communication protocol. And then in this case too, even if you run the GUI and hardware on the same device, you could still you wouldn't have to change anything, because they would still use those queues. You could remove the communication part from the application and mash them together, and they would still be dependent on the same thing and function exactly the same, because because they still just use the queues that's from a third-party library. You could delete the cons part altogether. So that's kind of the approach to this. And my point is really, you have to just be aware of who uses which type defs, and then take a decision based on that. Next, we can look at data types. They're used in the hardware. So it would be natural to maybe use them in the hardware. But if they are owned by the hardware library, then now the GUI would be dependent on the hardware, and we don't want that, because maybe we'll change hardware later, etc. Maybe we'll replace it. So who should own it? The GUI can't own it, because then you get the opposite problem. What we could do is just to add it to the communication interface library, where we put the queues and the communication data. But and that could be a good solution. But now the communication is bound to specific data types. Maybe you want it to be data agnostic. If this is not a problem, then that's the perfect solution, and you can always move it later, which I will show. What I would do is make another library, which I just call the data type library, or what I usually make is like a package class which contains all the data types, and then a child for each data type. But I won't go into that. But again, if it's owned by an external data type library, now RT is dependent on that library, the GUI is dependent on that library, and they have no codependency, or like they're not dependent on each other, and it again is not dependent on anything else. So we follow the rules: no circular dependencies, no dependencies between the PC software and the RT. And keep in mind, these can all be in the same project, so there's not a issue against that. It's just they shouldn't be dependent, because that causes a lot of weird problems, as I explained earlier.
There is a question from Vihad. Yeah. Do you want to take it now or later?
I just had one question about this slide. You talk about the communication interface owning the data types, but isn't that against the definition of an interface? I mean, an interface is data agnostic by itself, right? At least the LabVIEW interfaces. I mean, classes have a specific data type associated, but interfaces don't.
Yeah, that's why I actually said, yeah, I agree. That's why I had the one data type library and one communication interface library. But I was saying you could put them into the same, because sometimes if you have a smaller application, you can just, how can you say, you don't want to have infinite diversity, like infinite complexity when you're just trying to do something simple. So you could add them into that interface.
Okay, so
and you wouldn't break the rules.
A common library would hold both the interface and the data type, you mean?
Yes, it could be.
Okay. Okay.
It's multiple ways. It just depends on the complexity. But what I would do is have a communication interface library and then another, not connected to that, data type library, so that the communication interface would be agnostic. And when I say communication interface, you might be confused that maybe that you think it's part of the communication library, but it's not. The communication library is its own library. But then for anything that wants to interface it with it, they don't need to be dependent on that library itself. They just need to be dependent on the interface library, making it a lot easier to control your dependencies, if that wasn't clear.
Oh, got it now. Thank you.
Yeah, no problem. Yeah, it's good you asked to just clear up these things. So yeah, so that's the solution for this one, or a solution. There's multiple solutions here. I'm just trying to kind of problematize the issue, kind of trying to see all the solutions and why each thing is a problem. Next, we have the queues here. So the GUI queues just symbolizes that something is common for the whole PC application, because usually you would have probably more than 2 VIs, like more than just communication and GUI. Maybe you have some data handling, etc. Like just imagine there's something in parallel that also does something the GUI needs to communicate with, but I didn't want to add it to reduce the complexity. So who should own it? Since it's the PC root that initializes it, so one might think that it should own it, but then since PC root is dependent on the GUI, and then the GUI will be dependent on the root, you will have a circular dependencies. And also the communication queues are also not owned by the root. So what you could do is just have also them in a common library, where you might have features for initializing and closing them, methods or VIs, which then are used by the root actor. So again, like a common libraries could contain anything else that would be used for more than one part of the PC application. I often like to use these common libraries. I always have in all of my projects, no matter how big, I have like one common library for that can be used on every piece of the application, like in PC or RT. I just have it follow a few simple rules that it cannot be dependent on anything else in the code, and it's not allowed to use any classes or actor stuff. It's very simple, lightweight library. It usually contains paths, because I like to have my paths inside VIs, because then they can be reused, and if I need to change the path, it happens all over. I have a lot of time handling, like conversions and logging, or just some simple math stuff. And I don't want to remake everything for each actor. I use actors, I use classes, but libraries are in a way the same. I don't want to reuse it. I remake it, I want to reuse it, but I don't want to create weird dependencies. So that's why I very often, almost always, have like a common library for everything. Yeah, which just everything can be dependent on. Like I often create the rules before I start making a lot, because then it's easier to develop, because you already have made like some rules, so you don't have to kind of plan or like think about absolutely everything. Yeah. Okay. So for the RT queue thing, here it's the same discussion as with the PC queue, so I won't go into that. I've just used typedefs for this example, but it's the same procedure as for VIs. When you have a VI, you want to kind of think who uses it, which libraries use it. Can it be owned by one library and every other library is dependent on it without creating a circular dependency? Then that's fine. If not, then put it into a common library. That's kind of my simple approach to that. And just to kind of clarify one thing, like having a common libraries is not the silver bullet. I have like a very common thing I use Actor Framework, as I've said probably 10 times now. But the point is that I have a root actor which launches everything. Then I have a hardware manager which manages the hardware. And then I have a hardware class. The hardware class knows how to communicate with the hardware, but the manager knows when and why in a way. It would be very tedious to use a common library for their interaction, especially since the hardware manager uses so many of the hardware methods. So the solution is simple. I just use a one-way dependency. Hardware class is not dependent on any of the actors. And that's kind of important, I think. A class should never be dependent on an actor, but an actor can be of an actor, but there's always some exceptions. And then the hardware manager uses the hardware class and is therefore dependent on the class, but it's not dependent on the root. And then lastly, the root uses and is dependent on the manager, making it also dependent on the hardware class, but that's fine since it's only one direction. So that's kind of my planning around controlling your dependencies. The last step is just an example I recently did. You can see the code on the left. I have a unit test I used to test my real-time app. Oh, it's moving a lot. I used to test some of the conversions and some of the features of my application. So there's multiple ways of finding which dependencies, like what the library, the dependencies of a library. But an easy way is just to start a new project and then just drag that individual library in and then open the dependency tab. You will see everything it's dependent upon. And here you can see it's a lot in the FPGA. So this is not good. Yeah. So by right-clicking on why is this a dependency, if you right-click on any of the libraries in the dependencies and click why is this a dependency, it will show you which code that calls this library. This method takes a lot less time if you know something about the code. In this example, I knew it didn't call anything used in the FPGA directly, so there had to be something in my code that called the FPGA indirectly, so it called something that called the FPGA, so that was kind of my breadcrumb. And when you find the VI, which is the culprit, you switch project. In my case, it was 2 VIs and a few type defs used to handling the system voltage. So my next step is then I pushed my code to Git because moving files can be an issue. And then I create a new project where I add absolutely everything into, like just a PC project. You don't need to have the targets, but then you have absolutely everything in there because LabVIEW is very sensitive to changes. When you move a VI on the disk or move a VI from one library to another, it is very it gets very pissy if it's not able to be part of the process. So I always do it within LabVIEW. So what I do is then move the file from where it is to the correct library. This I usually do by right-clicking and pressing rename, and then I move the file or rename, but you can also do it there's a tab on top of where you see the folder structure where you can move multiple files. It's very important it's done within LabVIEW, because or else it will not be happy. Then I rinse and repeat, and open the other project again, and then do the same thing, because you don't always find all the dependencies on the first round. And then for me, this is how it ended up looking after a few iterations of looking. This looked more like what I expected. And as you can see on the right, there's a lot fewer dependencies than what on the left, which is just caused by me misplanning a few VIs and type defs, which were used, which is basically like they were owned by the hardware, which then used the FPGA, and instead I just moved them to a third party or an external library, which both can use them, and that removed all the codependencies, or not codependencies, but the dependencies here. So that's kind of how I fix it in the current code. That's my presentation on how to deal with dependencies and why you should deal with them. Any questions?
There have been something in the chat. Maybe Jonathan can very short say or something. A question about it is a tool to determine the dependencies, and Jørgen was saying something, but then Jonathan, I don't know if you will add something or you can just read in the chat about it.
There's multiple tools, yeah, so you can do it. I was just showing non-tool way of doing it. But it's good to use tools too, but sometimes maybe you can't download, you don't have the VI package manager, or you don't want to use it. And so you can do it the old-fashioned way I showed.
I've tried out the dependency inspector from Panther Labs, and also in the UML editor from OpenGDS you can view dependencies. I think nothing really super user-friendly also, but maybe also if you have a dependency problem, you really have a project that is fairly big. So that in any case, you will need to simplify and try out methods like Jørgen was showing. But maybe these tools can help, and I think there's interest in the community to make them better, and maybe even interest from an eye to maybe that it warns you actually when there's circular dependencies. But then we also do things like by reference, where we load stuff by path, and that can also cause maybe dependency problems when building, which would be very hard to figure out.
It really affects how big your application is, because mine is a few thousand VIs and type defs. That's the size of the projects I usually work on. So I don't know the size of other people's projects, but then it's really important, because it's probably not a problem when you have just a few hundred, but it always starts as a few hundred.
Exactly. I think one of the best advice, or somehow is that I always felt around, was to have a good folder structure which matches your library structure in your project. And I always kind of know where you have dependencies, or which things get called by which. So if you have the same picture in your mind as it would be in disk, or it would be in the project, then it's much easier to handle as when there's just VIs pulled from everywhere. So having good folder structure helps.
Yeah, you have to have that too. I agree, because I just separated from classes, actors, and stuff, and then I have a folder structure underneath there. And because it's a lot to handle when you have a few thousand VIs, because suddenly you use a temperature sensor and then you put it in your GUI or whatever, and then you just chain of dependencies. You're just trying to do something quickly. That's kind of the point of the talk. I don't know what people expected, but if it was relevant for most people, but this is relevant for me almost every day.
when you work in your team, you said you were 2 or 3 people in the team, right?
Yeah.
Do you have a way of visualizing how you are planning to build up the structure in the beginning of a project, for example? Like, we want the dependencies to work this way, or how do you discuss that in your team?
Because you just how I do it is I decide kind of the direction. You can say you make this code now. Don't put any of what you make, and nothing of this part of the code should be dependent on what you make, but you can draw dependencies your way. And we have like a rule: these libraries are common libraries, but these are not. So if you see a type def which you really want to use, then we'll make an interface. Then we'll make, or when I say interface, it doesn't have to be a LabVIEW interface. It's just call it a interface library.
Yeah, so you decide that, okay, we need to handle this in some way so we don't get the dependencies.
Yes, and then as you can't plan everything, you kind of you just, when some people notice, oh, I will reuse a lot of these type defs or VIs, because I don't want to remake everything, because then that makes maintenance a lot harder, because you will have to, if you remake every type def, for example, and then you need to add element to it, then you need to add it to 5 different places. That's too much work, so you don't want to do that. So what you do is then, if you notice it, you just make it as you need it. You don't necessarily know everything in advance. People just have to communicate and see, now I want to use this, and then you kind of find a way to do it. Did that answer your question?
Yes, it did.
Okay.
Thank you.
Yeah, no problem.
So to follow up on that question, sorry, just to follow up on the question, like, do you communicate it orally, or do you like drop a chart or something like that to say these, I mean, these are the libraries that we need to have, and like, you know, the state chart module, for instance, you have a state diagram sort of. So do you have something like that?
It's
okay.
Orally, if we can. If we sit next to each other, if it's remote, we just type it. Like you say, oh, I noticed this, and then we just have a chat and show in the video, or we kind of just make the mistake in our own branch and then show it, and then you kind of have to deal with it. Or we merge, then in the common branch, we fix the issue, we kind of split it, and then we split up again.
Okay.
Yeah. There was someone else?
Yeah, I could just add that drawing system diagrams is always very helpful. We use Miro for it as a general like whiteboarding tool, but there's also like draw.io and many other ways. Draw.io is really good to like draw up a diagram. How does your application should work? And if you want, you can go into specifications like, okay, this should be a library, this should be a class. And parts of those things can also live with the application. Like it could be with source control, draw.io drawing file. Can be part of documentation.
Yeah, we use Draw.io a lot, but the thing, I'm just trying to be pragmatic. So for the big things, for the managers, for all the big things, it's very clear what the direction, what it should be. It's just for the smaller part of the code, that's when the complexity happens. So we draw a lot of diagrams which people can follow, and then but then the issue comes with the small stuff, like you have a library which just uses one thing and then you use it there, but it was dependent on that, and that's kind of where, because it's hard to draw a diagram where every library and every VI kind of exists in. So it's kind of trying to find the middle ground of drawing enough to kind of show it, but also finding the middle ground is the hard part.